So, how common is helium? Well, did you know that helium is the second most abundant atom in the universe? 25% of matter in the universe is helium. The Earth contains very little helium, though. The reason for this is twofold. Because helium is unreactive, it is unable to combine into heavier molecules. The lighter gases in the Earth's atmosphere, such as hydrogen and helium, were once abundant. However, they have boiled off over the eons. Because helium was only ever found as a lighter gas and never combined with other heavier atoms, it was evaporated away. Helium is the second atom on the periodic table. It has an atomic number of 2. Welcome to the fascinating world of helium. Helium's simple atomic structure, consisting of just 2 protons, 2 neutrons, and 2 electrons, gives it its unique properties that make it truly special. Its first electron shell is full, so it has the tendency to be stable, as it doesn't need to lose, gain, or share electrons in order to get a full shell. Because of this, helium is inert, unreactive, and it is part of the noble gas family of the periodic table, a family of gases that don't react with other atoms. Helium was first discovered in 1868 by French astronomer Jules Janssen during a solar eclipse. However, it wasn't until 1895 that Scottish chemist Sir William Ramsay isolated helium on Earth, making it the first noble gas to be identified. Why was it so hard to identify noble gases? They don't react with other atoms. Because these atoms have a full allotment of electrons in their outer shells, they don't undergo the normal chemical reactions we need to observe to identify them. Chemists such as Mendeleev, who developed the periodic table, proposed the existence but were unable to find these elements. Later, scientists developed new techniques to identify atoms through the unique emission spectral lines they produced. Helium is well known for making balloons float. However, in the early 20th century, many large balloons were filled with the alternative hydrogen gas due to its lower density and producing a larger buoyant force. Hydrogen was also easier to obtain. Like hydrogen, helium is lighter than the gases that make up air, mostly nitrogen and oxygen, lifting the balloons with its buoyant force. Unlike hydrogen, helium does not react with other atoms, so it will not explode, burn, or corrode, making it a safer alternative to hydrogen. Helium has a unique property. Helium becomes a superfluid at temperatures close to absolute zero. This superfluid displays remarkable properties like zero viscosity. That means it flows very, very quickly and easily, and the ability to flow without dissipating energy, and so it doesn't lose energy through friction when it does flow. This unique state makes it crucial for various scientific experiments. Helium's use in cooling. Helium's low boiling point makes it an excellent coolant for varying applications, especially in cryogenics. When helium evaporates from a liquid to a gas, or boils from a liquid to a gas, it absorbs heat from the objects that are around it. Helium has a boiling point of around negative 269 Celsius or negative 452 Fahrenheit. So, helium can cool objects down to these very low temperatures. These low temperatures are needed to cool superconducting magnets and MRI machines, and to maintain the extreme cold in particle accelerators. Because of this, helium plays a vital role in scientific research. So, Can we find helium on Earth? Well, it's difficult. Despite its abundance in the universe, helium is relatively rare on Earth, though the Earth does produce its own constant supply of helium through the radioactive decay of unstable isotopes within the Earth. This radioactive decay produces heat that drives convection currents that cause volcanoes and earthquakes, and alpha particles that will eventually become helium gas. Most helium gas collected on Earth is extracted as a byproduct of natural gas processing, gets collected in natural gas deposits. However, with increasing demand, there is a growing awareness about the need to conserve this valuable helium resource so there is enough left for future endeavours. Helium in space exploration. Helium is a key player in space exploration. Liquid helium is used to cool infrared detectors on telescopes and in spacecraft, enabling scientists to observe distant celestial objects with unparalleled clarity and allowing us to send spacecraft to the extreme distances needed to reach other planets in the solar system. As we think about sending manned spacecraft to Mars or further, helium will become an essential resource for operating different machines within the spacecraft. Helium's voice-changing effect. Inhaling helium can be a source of amusement due to its temporary effect on vocal cords. Because helium is less dense than air, vocal cords will vibrate more quickly in the less dense gas and produce a higher frequency sound waves. These higher pitched sound waves are observed as a higher pitched voice, creating those funny and memorable moments we've all experienced. If you plan to inhale helium at your next party, just take care. Inhaling too much at one time can cause dizziness, nauseousness, or maybe even death. Helium supplies in the future. As helium demand continues to rise, there are concerns about potential shortages. It is crucial for us to explore alternative sources and promote responsible helium use to ensure the sustainable future of this extraordinary gas. Beyond the Earth, the gas planets such as Jupiter, Saturn, and Neptune contain large reserves of helium. Also, our atmosphere is constantly bombarded by helium nuclei that are constantly being released as products of nuclear reactions occurring in the Sun. So, if we want to keep using helium in the future, we might have to think of ways to go and collect it from our neighbouring planets, or look at better ways of conserving it when we do use it.